Hello dear students of class 10th. Very good morning all of you. I hope you all are doing well and doing a study at your home. Dear, here I am going to start the next topic, that is the liver. Okay? This is the third part of chapter 3rd. Okay? That is machine. Here we are going to start the topic that is called as liver. A lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. Means simple, we can say that lever is a what? A rod, a bar. Okay, you may call it as a lever. Okay, either it may be in bent shape or either it may be in a straight bar. Okay, rod, that is called as lever here. Okay, now here let's suppose that this is a bar of what? Made up of metal. Okay, and let's name it A and B. Okay, this is a lever which is fixed at a point, about a fixed point about which a lever rotates is called as fulcrum. Fulcrum is a fixed point about which a lever will rotate. Okay, to turn a heavy load, to lift a heavy load. Okay, it is a fulcrum. If anyone asks you what is fulcrum, fulcrum is a fixed point about which lever will rotate. Okay, here a lever works on the principle of moment. I hope it is in your mind, principle of moment, that anti-clockwise moment is equal to clockwise moment. In the same way, a lever works on the principle of moment. It means if anyone asks you state the principle of lever, the principle of lever will be same as that of principle of moment. That is, anti-clockwise moment of a lever is equal to clockwise moment of a lever. Okay, so here a lever works on the principle of moment. According to it, moment of load about a fulcrum must be equal to the effort moment of the effort about the fulcrum. Okay, it means that what amount of moment of what lever about load about the fixed point fulcrum by the load will be equal to the moment produced by what? Effort about that point, about the point of fulcrum. That is, clockwise moment of load about the fulcrum will be equal to anti-clockwise moment of the load, moment of the effort about the fulcrum. Dear, here I have written some another words also, that is load arm or effort arm. Load arm is a shortest distance between the point of axis of rotation, that is fulcrum, and the load. Okay, it is the shortest path, it is the shortest distance between the load and the axis of rotation, that is fulcrum. That distance is called as load arm. Okay, load arm. And same way effort arm. Effort arm is the shortest distance between the effort and the point of axis of rotation, that is fulcrum. Okay, that will be called as effort arm. Dear, here I am going to calculate according to this. We are going to find the moment. Okay, clockwise moment or anti-clockwise moment. Clockwise moment of load. Dear, I want to find the moment. We know that moment is equal to force into displacement, force into perpendicular distance from the what? Axis of rotation. So moment of load will be equal to load into load arm. Okay. Simply moment of effort will be about fulcrum will be effort into effort I hope you able to understand it. It is so simple. I'm just taking L for load and LA for load arm. Okay, it is a short notation. L for load, LA for load arm. Okay, dear. E for effort. Okay, into EA means effort arm. Dear, if we divide it, okay, if we divide effort to here, load upon effort, that is equal to effort arm upon load arm. Okay, so this is equal to load upon effort is equal to mechanical advantage, as we know from last class. So mechanical advantage of a lever is equal to effort arm upon load arm. Just opposite. Load upon effort arm upon load arm. Dear, I hope you understand it. Mechanical advantage of a lever will be written as effort arm upon load arm. Okay? For convenience, I have written it. Okay, dear. I hope you will find it easily. Now, we will move to the next topic, that is types of lever. Dear, types of lever mainly on the basis of what? The fulcrum, where the fulcrum will be present. According to this, types of lever is divided into 3 types, that is class 1 lever, class 2 lever and class 3 lever. Okay, so I am going to write a summary, or I am going to explain you in a very simple way, that is this all 3 types of lever. Okay, dear, just a minute. Lever is basically divided into 3 parts here. Basically divided into 3 parts. Okay. Lever is divided into 3 parts. First, class 1 lever. Second, class 2 lever. And third, class 3 lever. Okay. Class 1 lever. Dear, for remembering this, it is so simple. Just you have to learn a word flee. Flee. F-L-E. F-A-E. These 3 letter you have to, what these 3 word letter you have to just be in your mind. Flee. F-L-E. Class 1 lever. The lever in which fulcrum is in mid between load and effort. That type of lever is called as class 1 lever. And for load, the lever in which load is lies between the effort and fulcrum is called as class 2 lever. The lever in which effort lies between the fulcrum and load, that type of lever is called as class 3 lever. I hope you are able to understand here. Okay? So I am going to draw a diagram, a lever in which fulcrum is in mid, is called as what? Which type of lever? They are class 1 lever, in which load and effort by side. Load and effort. Between load and effort, fulcrum will be present. Okay? In class 1 lever. Okay? In class 2 lever, load will be in the mid. Okay, dear? So, I am going to make a simple diagram. There is a lever in which fulcrum is present over here. Fulcrum is here. Okay? And load is here. Effort is here. Okay? I am simply making you a presentation for you. Okay, dear? To just be clear about class 1, class 2 and class 3. After that, I will explain you each class one by one with examples. Okay? Dear, when load is in between fulcrum and effort, then this type of lever is called as class 2nd lever. Okay? Its load arm is less than its effort arm. Its load arm is less than effort arm. In this case, we cannot guess. It may be less, it may be greater, it may be equal. Okay? In this case, always load arm will be less than effort arm. Okay, dear? In this case, load arm may be equal to effort arm. Load arm less than effort arm. Load arm may be greater than effort arm. These all three cases will be lies in case class 1 type of lever. Okay? These all three cases may be possible in class 1 type of lever. While in class 2nd type of lever, only load arm will be less than effort arm. Means that effort arm will be greater than load arm. I hope you are able to understand here. I will come to the next one. Next. Okay? Coming to next. If fulcrum is here, now effort will be in mid and load will be here. I hope load will be here. In this case, dear, effort arm will be less than load arm. Dear, I hope you are able to understand it. In this case, effort arm will be less than load arm. As the picture says, as this picture is saying that, I am not doing some extra thing, I am just fragmenting this all. Okay? So, as we learn here, mechanical advantage of a lever is effort arm upon load arm. Effort arm upon load arm. It means mechanical advantage of class 1 lever will be or may be equal to 1 Mechanical advantage of class 1 lever may be less than 1. Mechanical advantage of class 1 lever may be greater than 1. These all three cases may be possible in class 1 type of lever. Why? In class 2nd type of lever, mechanical advantage, as we know that effort arm upon load arm, so always mechanical advantage will be always greater than 1. Will be always greater than 1. Because here, understand, here load arm is always less than effort arm. That's why after dividing effort arm with load arm, you will get always greater than 1. So, mechanical advantage of class 2nd type of lever will be always greater than 1. Coming to the next, class 3rd type of lever. Class 3rd lever has the mechanical advantage. As we know that mechanical advantage, effort arm upon load arm. Okay, dear. Here, effort arm is less than load arm. So, mechanical advantage of class 3rd lever is always less than 1. Dear, here, please understand. Make clear in your mind. Make it clear in your mind. Class 1 type of lever will perform all three functions which a machine do. That is, it may be speed multiplier, it may be direction changer, it may be force multiplier. Okay? Because mechanical advantage of class 1 lever is may be equal to 1, may be greater than 1, may be less than 1. Okay? That's why if it is equal to 1, it will be what? Direction changer. If it is greater than 1, it will be force multiplier. If it is less than 1, it will be speed multiplier. I hope you are able to understand. Dear, as class 2nd lever have always mechanical advantage greater than 1, it means it is a force multiplier. Means class 2nd lever will be always as used as a force multiplier. Okay, dear? It is a force multiplier machine. Force multiplier machine. Okay. It is a speed multiplier machine. Class 3rd lever is a speed multiplier machine. Speed I hope you are able to fragment or understand these all types of lever here. Hello dear students, here I am going to explain you some examples of class 1 lever, class 2 lever and class 3 lever. As we know that class 1 lever behaves as all three types of machine. Either it works as a force multiplier, speed multiplier or direction changer. While class 2nd lever always acts as a force multiplier and class 3rd lever always acts as a speed multiplier. Dear, come to the point. Now we have an example of seesaw, which always you find in the school garden or some public garden. Their children used to play by lifting their loads of one another. Okay, so there is a fulcrum in seesaw. Okay, at an equal distance there is a two seats. One is called load or one is called effort. The distance between fulcrum and effort is called as effort arm. and the distance between fulcrum and load is called as load arm. As load arm and effort arm are equal, so mechanical advantage of these types of lever is 1. So it always works as change in direction of effort. Here, as we know that mechanical advantage is equal to effort arm upon mechanical advantage is equal to effort arm upon load arm. So, as effort arm is equal to load arm, mechanical advantage will be equal to 1. It means seesaw is the lever which will act as a what type? Direction changer, change in direction of effort. Okay. Now, the second example is scissor. Dear, you might all have used the scissor or see any person who is cutting some piece of clothes by using scissor. Scissor basically works as a speed multiplier. It works faster. By using scissor, you may cut cloth very fast, very easily. Okay, that is a speed multiplier machine. How it is a speed multiplier machine? Let's understand. Okay, as you know that scissor has a small hole, two holes in which you just put your 2 fingers and 1 thumb. Okay, and there is a large shining region where you put the clothes to cut. Okay, that is called load. So, there you will find that the distance of load from the point where fulcrum is, load arm will be greater than effort arm. Load arm will be greater than effort arm. As we know that mechanical advantage is equal to effort arm by load arm. Load arm is greater, it means mechanical advantage is less than 1. So scissor works as a speed multiplier. Means scissor is a first class of lever which acts as a speed multiplier. There. Next, piler. Here, piler we use for cutting what? Wire. Okay, electric wire we use for cutting electric wire, turning electric wire. We use piler. In day-to-day life, you may also call as a what? Pillars. That is piler. Okay. Piler, you will find that piler hand is greater where effort to be applied. Hand is greater. While the cutting part, the usable part, where the load is kept and to be cut, is very small. It means here load arm is small, while effort arm is what? Very longer than load arm. So mechanical advantage is equal to effort arm by load arm. As load arm is what? Very less, while effort arm is very greater, more than load arm. It means mechanical advantage is greater than 1. So piler acts as a force multiplier because wire or any metallic substance is made out of metal, which is what? Tough in nature, and we need more force. We require more energy, more force to cut it. Okay, that's why we use piler, which works as a force multiplier. Now, crowbar. It is a very interesting way. This piler and crowbar alternately asked by board in your board exam. They alternately ask, one time they ask piler, then next time they ask crowbar. Okay, crowbar is a special type of bent lever. It is a bent lever, okay, which is used to what? Move a heavy load. There is a heavy load, okay. Here, this is the bent line. This is what called crowbar, okay. Here is a load. The distance between fulcrum and load is very less, while distance between effort and fulcrum is high. It means that effort arm is greater than load arm, so it will be also act as a So dear, in these all four examples, we will find that fulcrum is in the mid between load and effort, between load and effort, between load and effort. Fulcrum is between mid between load and effort. Okay, that's why these all are the examples of first class lever, and I have taken different examples: change in direction, speed multiplier, force multiplier. All three examples I have taken. Now coming to the second class lever. Second class lever has a mechanical advantage greater than 1. It means it works as a what? Force multiplier. Okay dear? So for example, nut crack. Nut is a very tough things which to be broke. Okay, so we use some type of machine that is a nut cracker, which is designed like this. Okay, here you will find the effort arm is what? Very large than the load arm. This is your nut present over between the two plates of nut cracker. Okay, so this will be called as a load. So distance between fulcrum and load is called as load arm, or distance between effort and fulcrum is called effort arm. As effort arm is greater than load arm, so mechanical advantage of this type of lever is greater than 1. Okay, so it works as a what? Force multiplier. Wherever just you lift and move. Okay, lift and move. Okay, and in this also load lies between the effort and fulcrum. Effort and fulcrum will work. Okay, raising the weight of a body on toes. Dear, as you raise your weight on the toe, okay, it means this is also example of what? Second type of lever. Okay, second class of lever. Now we are a bottle opener. You may also use as bottle opener. You will make in your mind that bottle opener is also an example of second class lever. Okay. Now coming to class third lever. Class third lever. Okay dear. Here are some examples of class third lever. For example, fishing rod, sugar pole, or fire tanks. Okay. So in fire tanks, we put a load here to just lift a fire or burning coal. Okay, we use this. So we just press here in the mid between the plates. Okay, so effort is in mid while load is here and fulcrum is here. So effort arm is less than load arm. Here effort arm is less than load arm. Mechanical advantage is less. Okay, less than 1. Mechanical advantage is less than 1 in also fishing rod. Fishing rod you just use it like this. But when you find that some fish has scratched your, okay, then you apply force on here and to just draw it out from the water. That's why effort is in mid of the rod, while fulcrum is this, okay, and load is this. So load arm is greater than what? Effort arm. So mechanical advantage is less than 1. So it will act as a what? Speed multiplier. In a hurry, you find that fish has crashed, then you fastly draw the fish from the water. Okay, that's why it is as a speed multiplier. Speed multiplier. Okay. So I hope here you are able to understand these all activities, these all examples of what? Class 1 lever, class 2 lever, and class 3 lever. Okay. Okay. Bye.